Hello and Assalamualaikum. So today I will present about the lab for series and parallel pump. So we are from section 1, group 5. My name is Muhammad Yusuf bin Saluddin and here is the list of my group member. First, I will start with the introduction. Pump are the device that are used to transfer fluid from a low rise location to high rise one. There are several types of pump and they are classified into two distinct categories, which is dynamic or kinematic and displacement in a positive direction. There are two common configurations of pump system, which is series pump and parallel pump. Pump in series are used to link the discharge end of one pump to the suction of the other one end. When the two pumps are linked in series, the head of two pumps can be added. Next is a parallel pump. When two or more pumps are connected in parallel, the resulting performance curve is calculated by summing the flow rate of the pump at the same head. Each pump will operate at the same head but share the flow rate with the other pump. Next is the problem statement of this experiment. One of the difficulty that the pump user typically confront is when many pumps are required to run simultaneously on the same system. It is possible to consider the operating characteristic of the individual pump to produce a single combined performance curve when dealing with a multiple pump system. There are two possible configurations when dealing with a multiple pump system. Next is the objective. So the objective of this experiment are first to demonstrate the pump performance curve for single pump configuration, series pump and parallel pump. Next is to investigate the relation between pressure head, flow rate, power consumed and efficiency for a pump. Next is to determine the characteristic of centrifugal pump, and then next to understand the concept of pump curve. And finally, the scope of this experiment. In the experiment, we are focused on the operating of the pump. The first configuration is series operation, which is one pump discharge directly into the suction of the second pump, with both pumps supplying the same flow rate but sharing the pressure development. The second configuration is parallel operation, in which each of two or more pumps draw suction from a shared header and discharge into another shared header, thereby sharing the flow rate while working at the same head. Then with the data from the experiment, we need to calculate the pressure head, power and pump efficiency.
Assalamualaikum and good day. So, my name is Muhammad Izzat bin Ahmad Suhaimi. My ID is MA18238, and this is presentation for chapter 2, experiment 4, which is the theoretical part. Okay, so a single pump could prove to be inadequate to generate the performance needed. So by connecting two pumps, it raises the pumping capacity of the system. And so two pumps could be proved to be correlated in series in such a way that water flow first through one pump and then through the second. When two pumps are utilized in series, the flow rate is identical as for a single pump, except the total head is greater. Okay, so when two pumps are joined in parallel, one half flow in the course of one of the pumps and another half in the course of the second pump. Okay, so when these two pumps are utilized in parallel, the total head increases, will remains unchanged, while on the other hand, the flow rate is increased. So these are the two graphs on the how two pumps in parallel affect flow rate and head, and how two pumps in series affect the flow rate and head. So it can be seen here that the head increases as the flow rate increases in the two pump in parallel. Sorry, I mean decreases. Okay, so for the evaluation of the net head to compute the net head, this is the formula given. Okay, so that's all for me. Thank you.
Assalamualaikum, my name is Omar Hakim, MA18237. Today I'm going to present chapter 3 method and procedure for series and parallel pump. The experimental apparatus that used for this experiment is water tank, manometers, control valve, and two identical centrifugal pumps. The system includes two identical centrifugal pumps that are connected together through pipes. Manual valve make it possible to switch quickly between series and parallel operation. Manometer is used to indicate the pressure at all important points in the in the pipe system. To record the pump characteristic, the water supply and volumetric flow rate measurement are provided by the apparatus. For the experimental procedure, experiment 1, first we set the selection. First we set the selection path to single pump operation configuration. For this experiment, we open valve number 5 and 6. Turn the switch to the left to switch on the single pump. Use the output volume to adjust the volumetric flow. Record the pressure suction, pressure delivery, and volumetric flow. Repeat steps 2 to 4 with a different volumetric flow. For experiment 2, series pump operation, firstly we set the selection valve to a series configuration operation. And for this experiment, we open valve number 5 and number 7. Turn the switch to the right to switch on both pumps. Use the output volume to set the volumetric flow. Record the pressure suction 1, pressure delivery 1, pressure suction 2, and lastly pressure delivery 2, and volumetric flow. Repeat steps 2 and 4 with a different volumetric flow. And lastly, experiment 3, parallel pump configuration. First, we set the selection valve to a parallel configuration operation. For the experiment, we only open the valve number 6. Turn the switch to the right to switch on both pumps. Use the output volume to set the volumetric flow. Record the P section 1, P delivery 1, P section 2, and P delivery 2, and volumetric flow. And lastly, we repeat the step 2 to 4 with a different volumetric. And that's all from me.
Assalamualaikum and good day. My name is Shafi Ahmad. I will proceed with the fourth chapter of the presentation, which is the results and calculations in the series of parallel pumps experiment. Let's go through it together one by one. Before moving into the findings, please keep in mind that there are a few boundaries and properties that must be considered. In terms of the boundaries, first, the water is considered to be at room temperature, which is 20 degrees Celsius. Second, the fluid flow is steady and incompressible. Third, the flow is turbulent and completely formed at the pump inlet. And fourth, there are no leaks between the lobes or between the lobes and the lining. For the properties, first is the density is determined from the properties of saturated table, which is equal to 1000 kilogram per meter cube. Second, the atmospheric pressure is equal to 101.325 kilopascal. And third, the power input for pump is 0.66 kilowatts, which is equal to 660 watts. Next would be the results for the single pump configuration. As you may see, the net head, water horsepower, and efficiency were calculated and summarized. Moving on to the series pump configuration results, the computed values of net head and water horsepower are shown below. Due to the table's limited space, we insert the computed value efficiency in the next table for easier tabulation. The final findings are for the parallel pump configuration. You can also see the computed net head and water horsepower values here. As previously, we put the calculated value efficiency in the following table for easier tabulation due to the table's limited size. Moving on to the sample calculations, as previously said, there are three types of calculations, which is the net head, water horsepower, and efficiency. Here, you may see the calculation of net head, which varies somewhat depending on the configuration. For a single pump, net head equal to the delivery pressure from the single pump over the multiplication of density and gravity. One of the sample computations were displayed. For series pump, net head equal to the summation of both delivery pressure from the two pump over the multiplication of density and gravity. And parallel pumps are similar to series pumps with the extra of dividing the equation by 2. Then there is water horsepower, also known as power output. For all configuration, the same equation will be used, which is the multiplication of density, gravity, flow rate, and net head. You may look at the sample calculations for each configuration on the slide. Then there is the efficiency. Single pump configuration is simpler since dividing the power output by the power input yields the efficiency number. The same equation is used for series and parallel, which is the division of power output by 2 times the power input. You may see a sample calculation here. I think that's all from me. I'll turn the stage over to my colleague to continue this presentation. Thank you.
Good day, sir, and my teammates. My name is Pang Jingyang, matrix number MA18211. I will proceed on a graph of chapter 4 and discussion of chapter 5. So let's discuss about the graphs. So from all graphs shown, all three pump configuration, no matter they are single, series, and parallel, all of them showing the same relationship between the pump head and the volume flow rate, which the higher the volume flow rate, the lower the pump head. So let's proceed with discussions. So there are three questions should be discussed in our experiments. So first will be compare the experiment performance curve to the theoretical curve and describe the discrepancy factor. So based on the experimental and theoretical performance curve, we can deduct the parallel pump has the highest flow rate compared to the others, while the series pump has the highest head compared to the others. The experimental curve result diverge significantly from the theoretical curve due to the fact that loss in the pipes and fluctuation of the flow rate during the procedure providing erroneous data for the experimental outcome. For second questions, from the result obtained, state the use of the series and parallel pump. So from our experiment, we found that a series equivalent pump is used to produce an output which is twice to the head of the single pump, which can bring a significant effect on the supply flow rate and the net head to the system. Whereas the parallel pump configuration is used to increase the flow rate to double of the single pump while not changing the net head. So last question will be explain why the system with series pump configuration would generate a higher pressure than the parallel pump configurations. So for the series pump configuration, the higher pump intake is consumed to overcome the high load, which is return generating a higher pressure head, while parallel pump configuration is having a header structure that connect two pumps which lead to the same pressure and discharge interaction as they are joined together. Thank you.
Hello and Assalamu alaikum. We have met before. My name is Shafi Ahmad, and I'll finish the presentation with the final chapter, which is the conclusion of the experiment. As a result of this experiment, we can conclude that the pump performance is based on its inherent qualities as well as instrumentation and design approaches. From this experiment, we also identified and investigated the relationship between pressure head, flow rate, power consumption, and efficiency. Furthermore, the data on pump performance for single, series, and parallel pump configurations were explored for this experiment. The practical and theoretical results show that when the flow rate lowers, the pump efficiency improves, and that proves the efficiency is directly related to the flow rate. The flow rate and pressure head are heavily influenced by the arrangement of the pumps. According to the data, the parallel pump arrangement has the greatest flow rate, while the series pump configuration has the largest pressure head. Additionally, each pump arrangement has a distinct use. A single pump setup can be employed for normal and simple use. A parallel pump design, on the other hand, may be utilized for a higher flow rate system, and a series pump configuration can be used for a high pressure head system. That's all from us. Thank you.